Okay, so good evening, everyone. Whoever joined the debate right now. So I welcome you all to this amazing debate, and this is on C++ versus Java. So here will be understanding the different pros and cons of both the languages, and we'll have uh, two sides of this. Like one is C++ and then one is Java. So we'll understand the insights of which language should we choose to begin with, right? And we'll understand the differences, both the pros and cons of both the languages. So today in this debate competition, we have two people. On the one side, there is Rajarshi Basu, who is an NUS Undergrad Researcher, silver medalist at IOI, and ex-CodeChef Contest Editorialist, and a student volunteer. So he will be speaking on C++. And on the other side, we have Saptarshi Mukherjee, who is an SDE at Google and an ICPC to 2019 Regionalist, who will be speaking on Java. So I first of all invite Rajarshi Basu to give his points on C++ and I'll just invite Rajarshi Basu. So Rajarshi, you can start now.
Hey, thanks for having me. I hope I'm audible. Just as a disclaimer, right, I started programming in Java and then I moved to C++. So this topic is kind of close to heart. That said, I believe that C++ is a better language to start with instead of Java. And here are some of the reasons why. So, firstly, C++ is easier to get started with in the sense that you don't have to worry about object oriented programming when you are initially writing your code. So, for example, in Java, you have to write a class and then a main method and so on. And you still have to know some amount of what is a class, what is an object, so on and so forth. But in C++, you don't have to go through that hassle. You just write a function, write whatever you want to inside the function, and you are done. So the object oriented part is fully kind of optional. Second, C++ is a strongly typed language. It has proper data types, and it has like structures and so on and so forth. And it is like quite different from weakly typed languages like JavaScript and Python, which most people these days start coding with. And I believe typing in strongly typed languages might be a bit more challenging at first, but then it is much more helpful in the longer run. Even if you like write a program which is like more than 100 200 lines of code, uh, the advantages of using a strongly typed language will become much more apparent, because then you don't have to figure out, oh, what does this xyz variable mean? Does it store a number? Does it store a string? In Python, who knows? But in C++, that's not the case. uh, Third point I would like to mention is, and this is sometimes taken as a negative, but for me, if I were to like start programming again, I would definitely do this. C++ is much closer to the machine, and so you are exposed to like a bit more advanced concepts like pointers and so on from much earlier. And it might be a bit more difficult in like maybe the first 3 4 days, but it's much more helpful if you get an understanding on these concepts in the beginning, rather than like program for like maybe a year or so in Python, which is like a super high level language, and then suddenly you want to shift to a lower level language, and then you are like, oh, what do I do with pointers now, or how are arrays declared? Because languages like Python and so on, they gloss over a lot of the details. In Python's, for example, you like the concept of arrays and lists are very blurred. In C++, they are like two separate entities with separate like properties and so on. And I believe like learning this from the get-go is much more helpful than learning it like 6 months later. Uh, so initially I said that when you are starting to learn C++, you don't have to deal with object-oriented programming, right? But C++ is a semi-object-oriented programming language. So there you get all the features of object-oriented programming in C++. Some a bit weird, some that are good to avoid. For example, the deadly diamond of death. But the thing is, you don't necessarily have to use that. It's there in the language, but if you don't want to use it, don't use it. But the fact is that it still has a very robust support for object-oriented programming. So like once you get off like the very beginner stages, once you're like maybe a month into programming and you want to uh, do a like kind of deep dive into OOP, C++ is good for you as well. You don't have to shift to a new language to like learn object oriented programming. And lastly, since CodeChef is a competitive programming platform, I'd like to say a couple of points why I think C++ is good to start with in competitive programming. First, you write shorter code. I remember me writing depth first search code in Java, and I had to like use external stacks and so on and so forth because the Java stack like the stack size is limited, or like you basically take input in Java. It's so long. C++, it's just basically like literally C in input. So all these things are very helpful in competitive programming. Second, C++ does not have a good, I would say, debugging system, or like an exception handling system. Why is this good? Why is this better in the long run? Well, you kind of hone your skills of noticing errors without you getting exceptions before. So, for example, if you are writing a certain piece of code, um, if you are practiced in Java, you will kind of expect that, okay, when I write the code, I will get some error message if there is an error, and then I'll figure it out which line the error message is coming from. In C++, it's much harder to do. The compiler spits out like a 50-line warning or error. And usually it just gives like a segmentation fault. Now, what to do with the segmentation fault, right? It's much harder to debug. So internally, what you kind of start doing is when you're writing the code, you become much more aware of what you are writing. And over the long run, you make very few such mistakes. um, Again, this maybe takes a couple of months, 3 months, 5 months time, but then if you learn if you learn programming in C++, you are much lesser inclined towards making silly errors like uh, array index out of bound kind of errors than if you ever programming in some higher level language with like good exception handling. And finally, if you are serious about competitive programming, then 99% chance you will move to C++ anyway. So why not just start with it? Um, so yeah, these are like more or less a summary of why I feel C++ is a better language to start with. And if I could do the entire thing all over again, I would probably have started with C++ rather than Java.
Thank you so much, Rajarshi, for giving us enough points to like how why should we start with C++. And we can also see many comments also. Many are liking writing C++ is best, and like we can see the comments as well. But there is a higher fan base for Java as well. So next, I would also like to invite Saptarshi Mukherjee for giving us like some points related to Java. Why should we start with Java? So Saptarshi.
Well, thanks, Umang. Can you hear me?
Yeah, yeah, sure.
Yeah, great. So yeah, in fact, it was a nice start with Rajershi's part on C++. So indeed, like when I first heard about this topic, I had to go back 9 years because that's the time when I started on programming. And when this topic comes for computer programming, it's slightly different for me because I started on programming about 9-10 years back, and then I switched to computer programming almost about 5 or 6 years later. I clung to plain simple programming for quite a decent period. So anyway, now I have to slightly deal with the two different situations because there are two kinds of candidates. And I think considering the fast-paced situation that we have to the fast-paced kind of practices, it's more likely that a student starts with computer programming and within 2-3 months he picks up programming just the way I picked up. I took maybe 1 or 2 years to pick up. So anyway, uh, rowing along the same path that Rajarshi took, I would definitely say that the intricacies which C++ brings to us and many of the things because in course of my mentorship and things, I had to deal with all kinds of languages. So none of these languages are unexplored for me. None of the very common languages. Uh, yeah, sure, Nishant. Okay, is there a problem? Is there some
Mm,
audibility issue?
I don't think there is an issue, but I think
Okay,
you
okay.
can speak louder.
Sure. So there is this one thing which I would definitely like to emphasize when starting on Java is that when I started it at a time when I had no idea of programming, when I was at a very slow pace, the best thing about Java was that it was the simplest, which is a very vague term, and the most straightforward to me. And today, when I look back at Java, that's what strikes out, what stands out. It was pretty straightforward. You want to do something, there are 10 lines often when it comes to things like file handling, which was perhaps the longest of things that I have seen in the whole Java programming. There were long lines of code, but they were straightforward. When I say straightforward, the simple things that I mean is when we are trying to access a location of an array, when we are trying to store something, when we are dealing with the same data types that Rajesh mentioned, we are like typing and we are maintaining the data types. Everything has got a perfect rule. You have to abide by that rule. You may have to write extra lines of code. When you write that an array is being defined or initialized, it automatically means that the memory has to spend that many units of time to put down zeros in all the all the values of the array. Basically, all of them need to be initialized. What this basically means is that the memory is spending sufficient time behind certain things which often gets classified as not necessary, but it means that it is always defining everything to be a very strong standard. I'll come back to this once again, but before that, just visiting the things quickly. There are no complex stuff like pointers. What pointers give us, which I definitely agree that they give us a lot of confidence, a lot of control on many things. I think they are not required for computer programming. So, having been staying in Java for such a long time and having been doing computer programming for quite a long time, I didn't face that I required pointers ever. So, and if we look at a beginner, and if I go back to my time when I was a beginner, maybe the part of pointers and similar things can be avoided. The important thing, going along the line that Rajarshi mentioned, is the data type. Definitely, data types need to be present when a beginner is starting. So I would definitely keep Java and C++ both in preference over Python. They are definitely good languages because a beginner has got a good understanding of where to use which thing. Having said that, there is also the provision of auto in C++, where I think maybe Java, having not allowed such things, provides us a more, stronger adherence to the data types. We need to cling to the data types. We need to know the data types. At a certain moment, if auto makes it a habit that you don't have to worry about this, suddenly when you're using pointers or certain methods to deal with certain things, it can suddenly run out of your mind. At a certain point of time you can feel that okay, it made it a habit for me not to worry about it, and now I don't know how to deal with it. So I think that in that case Java is stronger. There are other things. uh, Simple go to statements are available in Java. You can use it though it is not a standard, but it helps in computer programming. There are easily available templates. We know that this is quite unpublicized or unhighlighted because so many coders are in C++. But in Java, you actually don't require to know OOPS. There is something I didn't expect, but anyway, we don't require to know OOPS. The simple classes, the simple objects, there are very simple things that you need to know. For C++, we know that structs often become necessary for simple comparator sorts or something else. And the similar concept, just translating that in Java requires a bit of a class. And that's the only thing. If you don't have to proceed to the problem number D up to problem number C in code forces, or maybe first few problems in CodeChef, definitely won't require even that much of classes and interfaces or any version of them. There are other things where, in low level terms, Java I feel is robust, which is the accessing of invalid indexes. If you want to access an index which does not exist in an array or vector, then Java will stop you right over there. Now, I heard this point in terms of exceptions and those things. I don't know if they are in the same line, but definitely Java provides these checks, which helps the debugging or certain things quite easier. And maybe the beginner would be getting aware of these things at the exact moments when they get. Once again, like if we also focus on hash maps, when we search in hash maps, now there are many different ways you can have with brackets, you can have dot at and many other things. But in hash maps also, if a key does not exist, Java will surrender right over there. And this surrendering is in a way, even when you go to development, you will find that this practice is quite highlighted. That if a thing is facing an error, just cause an exception right over there. Just come out of the program, just finish up. The production should not deal with it. So I think this practice is not bad for a computer programmer, and for any beginning programmer, this makes sense. In addition to it, there are certain other things which I have been through. Prefix and postfix operations are very less required in computer programming. But when you want to have a good knowledge of the standard things which I mentioned, Java deals with standard things, straightforward things. If you make a complicated postfix or prefix operation, they'll not work in C++, and that has got its own internal architectural reason. It will give you wrong results. But when you come to Java, it will always satisfy it. So there is some complex architecture which sometimes takes more time, but with so many people coding all around the world, it also makes sense to dive into this particular language, deal with it strongly, get like know everything, and then everything is going to work when you have a standard knowledge of everything. And that's it. No use of structs and only classes. And I think other than that, everything will basically work in Java. Apart from that, I think before finishing quickly, there are many things which you need to be aware of as C++ programmers, apart from the basic structures of programming, which is when you're calling a function, when you are sending some array or something like a vector, you need to make sure whether you're passing by reference or passing by value. This is something where Java again, straightforwardly tells that you have to pass by a reference. And in some cases, there is a problem in passing an array, you have to pass a vector. And there are some other things which I have found that it is much more straightforward in Java. You want to pass an array, it will be passing by reference. Nowhere you will ever face the situation that you are going to pass an array and it is going to be passed by value, and that will cause you a TLE. Now, I know the best coding conventions are that you will keep it global, but still coding conventions come much later. For a beginner, when you get one standard way of doing it, when you know the reasons why that is the standard, it definitely enriches your mindset. After that, yeah, we can make our choices. Shifting to C++ definitely brings in a lot of things, but these are what I'll primarily keep for for choosing Java.
Thank you, Saptarshi, for giving us again so much points. And I actually thought of like switching to Java by listening to your points. But well, okay. So now I'll like to ask Saptarshi only to like raise some questions or find some loopholes in Rajarshi's point if you want to like have some type of productive conversation. Like whatever Rajarshi told, can you find a loophole in that or something else?
Sure. So there is this oops thing which I'll mention in very short. Uh, Having coded in Java, and definitely to some extent, you will also agree that we don't face it like a hassle. There are a few things which we start with. Input stream reader, buffer reader, they are also behaving like those kind of objects, object class interface and those things. But once we get accustomed to it, there are very few things which we can even copy from other programmers. So I think in terms of the oops thing, yeah, when we are shifting from computer programming to development, the basic oops thing which you mentioned was is possible for C++. I think that is possible for Java as well. And the starting point hassle, which you mentioned, which is an unnecessary part of Java's journey, I think that is not too cumbersome because you don't require that for too many problems. Anyway, running to another point where you mentioned about DFS in Java. I know that stack size is a problem, and it is also a case that even in C++, even in other programs, stack size, unless you use tail recursion, the memory stack can cause you trouble. But considering all the questions that we have encountered in code forces, CodeChef, everywhere, it actually happens that the default recursion type implementation is well supported on Java, and it works at par with C++. And in very narrow cases, like we have one question in AtCode.dp, I think we had to shift to the queue-based implementation of BFS. So it is only in those particular corner cases where you find that a large number of calls will be made. It is known that it will be in one run. I think even in C++ will follow the BFS kind of implementation. So DFS, every Java coder I have seen, every template that I have seen always follows the recursion type method. Whether we are believing we are relying too much on the constraints or not, I have never had thought upon that. But definitely 1,000, like up to 5,000 or so, we can easily, or 50,000 or so, we can easily go if we follow tail recursion or such methods. But if we don't follow tail recursion, we can easily go up to the limits that C++ can go. I think I may try it, but that's what I see. And yeah, I think in case of pointer, I know C++ programmers have done a lot of PhD on that reference thing and on that dot thing. So anyway, come to Java, be free of dots and arrows. Make your life easier. I think Java helps you keep your life easier. Yeah, like anyway, from this I get reminded of one thing. From this keeping life easier, uh, when we look at hash maps and tree maps, now this is one thing, maybe it just came to my mind. We have certain different norms for pair and for structs. We know structs when we store structs or when we store objects. When we search by another object by putting the same values, definitely it will not map us to the same object. And that's the exact way it works in Java. When we store an object and when we create another object with the same values, we cannot definitely map it. It will not inherently map it. But in case of pairs, it does map it. So there are certain things which needs to be remembered. A new pair will be mapped to the same values pair. In case of Java, like due to the absence of any other things, you need to use a class. So it is pretty straightforward. When we store it, usually what we do is using those values, we store what is the object for it. Next time we start using the object. So I think the variety of things uh, which might make life tougher, Java excludes them. The beginning part might seem a bit involved due to a few more lines of code, but I've always felt it enjoying because there are less ambiguity in it. So that's how I, conclude it. Umang.
Okay, Saptarshi. So now I would also like to invite Rajarshi for asking or for answering the questions which was asked by Saptarshi, and also I would also love to have your counter questions as well for Java, because I code in C++, so I don't want to be one way. So I want the C++ to become like heavier.
Okay, so just to start off, my experience is also very similar to Saptarshi's, because I started coding in Java, like that was basically like writing projects and so on for at least like 1.5 years before I even knew about competitive programming. So I guess we are kind of similar in that. Okay, so some points I feel uh, can be counted. For example, file handling, right? File handling or input output in general. Java is straightforward, but then C++ is also straightforward in that, and I feel like you basically in C++ you basically open a file and then you uh, basically read from it. Like there's no in between step. For Java, you have to open a file, then open a reader, and then you can basically do it. I mean, it's basically the same thing, but then to a beginner, if you have less lines of code, it's easier for you to understand. Like that's usually my experience in teaching. Um, so that was one. Second thing is okay. So you mentioned that Java, C++ has auto. Java also has var though in the latest in the latest versions. I think Java 10 or 9 onwards. It does have var. Or maybe even from Java 8. I don't remember the versions. But yeah, so it's not particular to C++. Um, what else? So the part about like Java being more robust at the memory level or like underneath the hood, that is definitely true, and I agree fully. But my only contention to that is as in it's good when you're doing development, definitely, because your programs are like maybe 5,000, 10,000 at least lines of code, and it's much easier to have exception handling, like proper strong exception handling to figure out those errors. But only for competitive programming, I would say, if you do not have those errors, it forces you to manually find the errors, and that in turn makes you write safer code. So that was like my first argument for like not having good error handling in C++. um okay, apart from that, I'll uh, just go with this one thing, the DFS recursion thing, because it was a big pain point for me when I used to code in Java for competitive programming. Uh, as a disclaimer, that was 4 or 5 years ago, and I used to use Java 7 mostly. Java 8 was not that popular back then, I think, or I don't know, God knows what. But in Java, if I'm not wrong, if you're passing in like 5 6 variables in the recursion stack, you cannot recurse more than 20,000 times or something. And I'm not sure how common these problems are, definitely in the later stages, because I use C++ exclusively for competitive programming only. Uh, but initially, I got like it was such an obstacle in so many problems that had a template of external stack based DFS code, because like at least 10 times it happened to me that normal recursion did not work, and I had to like use a stack to do the recursion separately. So yeah, like I'm not sure about current problems. Maybe they don't have proper like they don't have test cases which test the extremities of the recursion stack depth. But that is definitely a problem in Java, and not just for like submitting on competitive programming platforms. I feel like even when you're like creating test cases, so when you're creating problems and you're creating test cases for them, and you want to like randomly generate test cases, uh if stack size or memory size becomes an issue, it's, I feel, much harder to set the stack size in Java. C++, you just do some hyphen u limit and set it. It's much easier. That's a very like tangent point, but just like in the discussion, I feel like it's a bit relevant. Yeah. Lastly, tree maps and hash maps, the pair thing, right? I guess it's more or less similar, because Java basically does not give you a comparator for your custom pair class. C++ does, and pairs are really useful in C++, because like I have seen so many codes where you basically uh, create pairs of pairs, and then when you call a sort function, you don't have to make any comparators. The pairs get sorted automatically. Java, it's a hassle. Obviously, these won't come when you're a beginner in anything, but later on it does become a difference, especially in competitive programming. And secondly, hash maps is a bit of a trouble in Java, because if I remember correctly, the Java hash function is not good if not absent. And again, if I recall correctly, it's recommended that you implement your own hash function for all classes if you are using it in a hash map. So yeah, that's like an added bit of trouble for Java, which does not exist in C++. Um, yeah, so I guess this is more or less it. Um, yeah.
Maybe I'll try some short answers, Umang.
Yeah, sure.
Okay. So yeah, file handling, yeah, definitely. And I think I mentioned file handling just with that pursuit, that it is a bit complicated. When we come to file handling, we stop supporting Java basically. So that is that point. But I think again, file handling is not required. You have a very few set of problems. I think maybe which are the problems? uh, you want to like in Facebook hacker cup, you want to print the output in output.txt. For that maybe you can require, though in command line also you can handle that. In some other projects, maybe like in some other cases, I think some code forces problems, earlier code force problems had it, that you have to print it to output.txt. There are those 2 3 lines present in the internet, they are easy templates. We don't need to strain at all for that. None of the computer programmers do remember that. No, not even I remember that. Not even I'll ask anybody to remember that. So anyway, file goes out of the picture. I won't ever drag it into into the picture. There is another thing, auto. I think not only that auto is available, the thing is that auto is ubiquitously present everywhere across the programs for the common algorithms. So wherever we have these popular algorithms, we find that auto has been mentioned in the implementations. You won't find that for Java. So that is the first thing. Like I think it gets ingrained as a very common practice of C++. But anyway, having that additional thing, you can always choose not to use it. There's a third thing which I think I don't remember how you mentioned it. Straightforwardness, yeah. So a person will actually explore more and find out why a segmentation fault is occurring. That's right, right. So actually, I would tell my experience today morning only. I sat for the final question that I attempted in Facebook Hacker Cup. So there was one variable which I did not initialize. In all the places wherever I had done that variable equals to variable plus one, it immediately gave me a line over there that something is missing. It immediately showed me. I didn't have to compile it. So that is, I think, something that is inherent with Java compiler, which I do appreciate. Because anywhere else, what C++ does is just forget about it. If there is something stored over there, just contain it. If you are storing somewhere over there, we'll overwrite it. So there is a kind of belief that you're imposing. I understand that to be foolproof, a programmer should be aware of exactly what lines he's writing. But again, because it makes life easy for me, I would definitely support it. Debugging is easy because you don't just leave as a segmentation fault colon 11, which I keep on facing. I think somebody asked. I was doing some live sessions, and because of the students, I have to code in C++, and I'm not that good in C++. I always code in C++, and then there are some horrible things that I do face, all of the same name segmentation fault, and they are all of different galaxies. They don't have any relation. The issues don't have any relation among themselves. But anyway, that gets solved every time. Thanks to God for it. But I really feel that to be a programmer, you need to also understand how to debug. And if exploration makes your debugging much more better, I think that's also good. But Java makes debugging easier because of the standard way. You actually understand how the compiler reads it. The compiler reads which line first, then which line. You actually get the idea. And again, like, these are differences. And stack, yeah, I may have to research about it, but yeah, considering what I've seen people doing it, maybe it is due to the problems. Maybe it is due to the type of problems. That might be. And I know that there is a recursion limit, and recursion limit to enlarge it, it is quite hectic in Java. But according to my experience, it's not required. And for a beginner, definitely, yeah, keep to Java. You won't face this. He's just misleading you.
Rajesh, you like to speak something?
Um, I don't think like there's something I want to put in particular like refute in Saptarshi's answers. So
Okay.
There is certain thing very recently, maybe 2 3 months back, I fell in love with that PBDS thing. So I knew it long back, and then 2 3 months back I actually covered it. I actually felt that yeah, it's nice to have those things. But as a beginner, again, live
yeah,
with tree
you
maps,
don't
live with
really.
segment trees. You can.
Okay, Saptrishi. So one thing more, like for a specific, if a beginner wants to start competitive programming, like I can see the questions. Then which language you think should they start with? If if a beginner doesn't know any of the languages, he want to just start with any particular language, either C++ or Java, for a specific competitive programming. So I would you like to tell something on this?
Yeah. So in computer programming, the way I understand it, uh, first of all, what do we expect from a computer programmer? That a computer programmer shall know all the fundamentals in order to compete with other programmers. And when we mean by this programmers and competing with other programmers, there are only two things: data structures and algorithms. For data structures, you should have a fundamental knowledge of how these data structures are by definition structured. And then you should understand that with everything that you study in theory, there should be something in the language to provide you a one-to-one mapping. You can come to this language and you can easily implement this. And implementing this should not become an overhead, should not become a bottleneck. When it comes to algorithm, I think it depends just on practice. You can play with the things. The accessing part should be very easy. There should not be some unnecessary, uh, you know, rubbish things in the language that for accessing data or for doing some simple operation it's taking time. Once these things are there, any language is fine. I think in the keeping that in mind, Python actually provides two high-level, features, which can actually make a programmer either lazy or uh, mitigate the programmer's abilities to come up with different structures by himself. So definitely, I would recommend and strongly recommend Java and C++ over Python. So when he's entering to uh, computer programming and considering today's programmers who become programmers together with computer programmers, I would keep Java and C++ almost on the same level. Java has these advantages which I principally do feel and I've mentioned. You can always stay in Java. There are few things like arrays.sort and collections.sort. In arrays.sort, an array can take order n squared time to get itself sorted, which is inefficient. But with collections.sort, you actually can ride over those disadvantages. There are those things that you need to know. You can read blogs, and once you read blogs, all the basic things you can actually implement in Java as easily as you did in C++ or you hear your friends doing in C++. So I would prescribe Java quite strongly if you have to start for it. Then you can make a shift later on when you are aware of things.
Okay, so I also wanted to share experience with me as well. Like one of my friends started in Java in his first year, and I started in C++. And in my second year, like he asked me how to switch to C++. Then I asked him the reason. Then he said some things are turning harder to implement in Java. So what do you think can be the reason? Like there are some lesser resources for Java on internet or something else? Because we can see like our environment or our friends are majorly coding in C++ only, so it becomes harder to get some suggestions from our seniors as well related to Java specifically. And we can also see the comments also that there are lesser courses or some resources related to Java. Then what can be the right way to tackle this problem?
Definitely. Thanks for the question. And even I faced it. So when you look at, I think the common algorithms like Dijkstra or Prim's algorithms, when you look up that fat book, that Bible, CLRS, you actually see some complex implementations being written, Fibonacci heap and this heap, that heap. They make lives completely difficult, and you don't see any computer programmer implementing that. In C++, you usually find implementations over there. But for Java, I don't think there is any implementation which uses the simple data structure, which is tree map or tree set, yeah, tree map, I think. So keeping that in mind, yeah, definitely. If you have to think, I have to implement Dijkstra in Java. Suddenly, you ask some Java programmer, there is a chance that he won't be able to do it. Though he knows the algorithm, he knows that in heap the deletion time is ordered n, so I should not choose heap. I should try something else. He can get stuck. Uh, so that actually, and I've always felt it. The reason that C++ wins in most of the places among our friend circle debates is that more people have been brought into C++, and I've very strongly felt it. Even in colleges, the mentors, the seniors do ask the juniors that start with C++ because you'll find resources. That's right. But if you stay with the language, I think these are basic things, and you will gradually know how to implement it. As of now, I can't remember. PBDS can suddenly make a thing very easy. There is a, I'll keep that separate. But other things, I think it is quite easy. If you implement it second time, you won't face any difficulty implementing it. If you consider lazy propagation, the same lines of code are required in Java as are required in C++. Take DSU, same lines of code are required. Any of the standard implementations which can take you from uh, expert, min of expert to max of expert, or expert to candidate master in code forces, from 4 star to 5 star or 5 star to 6 star in CodeChef. They all can be implemented in the same lines of code in Java, apart from the rest of the template, which I don't know what I myself write. So from the rest of the template, only the coding section, I think it only depends on practice. So understand the fundamentals. There, I would still keep Java because there are a lot of resources. Just cling to any resource, do it. And many codes do match. It is not very difficult to convert a C++ code to Java code. But as you go to advanced level, maybe like observe which kind of resources are helping you. If the resources are not sufficient, make a shift.
Okay, okay, thank you. And one more thing, like I don't know much of Java, but like if for let's say take STL in C++. So can you tell me like what is equivalent library in Java?
We have collections, we have other libraries. Collections actually provides many things which are there in STL. We start with STL vector. and we start mocking at arrays. Okay, in Java you have only arrays. There is array list, which performs in a similar way, totally identical way as vectors over here. And again, if you use array lists, the sorting again, traditional takes order n log n time. There's absolutely no difference.
Okay.
Yeah, the sorting techniques are different. Totally different sorting techniques are used. Over on one side, you have double pivoted quick sort with some extra advantages. On other side, you have some culmination of merge sort and heap sort and many other things. But in terms of performance, it is exactly the same. You don't face any differences. What else? I think stacks and queues. The thing is that one should make it a habit to read the Java docs. Java docs have provided many things. If you read Java docs, you will see that they have told not to use stacks and queues. They have told to use DQs. Using DQs, you can do everything that you can do using stacks and queues, and the implementation is far more efficient as well as it makes sense. There is no wrong thing. In stacks and queues, maybe you can access some middle elements, which is against the theoretical idea and intuitions. So in Java, you actually prescribe that, okay, if you use DQ, then you cannot access the middle elements. I think in some cases, reading the Java docs can be a very good practice, and you get the entire idea what it is using. Read blogs, read Java docs. Uh, you have collections, and what else? You have many other things like I can't remember.
Like I just I'm curious to know like whatever things are there in the STL like vector, set, maps, or some all the different inbuilt functions like lower bound upper. Is everything in Java as well? Like the inbuilt functions which are in the inside SQL?
Yes. So for like whatever we require, I've never felt that okay, I have this in C++, I don't have in Java. Lower bound, upper bound also has something in Java, right, Rajarshi? Because I
I
think I
think I
have
think tree site has something like navigable maps or
the
something there.
three set definitely has it, but for arrays, I am not like for sorted arrays, I can't recall exactly.
So usually, like library wise, I don't think there is any difference. The main thing that does make a difference, which is not exactly a library, but it does make a huge difference in competitive programming, is pairs, because pairs in C++ makes your life so much easier. It makes your code unreadable for sure, but you can use pairs in complicated ways and do something in one line which in Java might have taken you a lot of lines. Yeah. By the way, like if I could chip in a bit with C++ Java, is that so the first year I did competitive programming, I did fully in Java. I had no knowledge of C++. Then I went to the IUI training camp. That was what in 2016. And then the thing is, you have support for both Java and C++, but it became such that I had to literally shift to C++ within like 10-15 days, because there are like like one thing, as you guys said, support for C, like as in the community for C++ is much larger in competitive programming, and second, there are some things that you really cannot do in Java, that you can do in C++. Like some complicated pointer arithmetic and so on and so forth, it becomes very troublesome to do in Java. That said, most good competitive programmers know both the languages, and I'll tell you why. um, there are like especially in ICPC, you get problems sometimes which uses like some Java libraries, like for example big integer or big decimal, and if you don't know that in C++, you are in for a tough competition. Like it becomes a very big headache. I think even in my last ICPC regional practice contest that we did, we had one of these problems, and our team, like I know Java more or less pretty well, so I could just do it in big end. So there's this concept that okay, Java might not have some libraries that C++ has, is more wrong than the fact that Java has stuff that C++ does not. Uh, so yeah. um,
That's right. But again, like I also know that using big integer, there was a situation I faced. I was pretty I just started at I pretty novice at programming. So anyway, I got a problem, and I felt okay. We have to do some modular arithmetic. Why spend time in it? Just focus on these things. big integer things. In Python, we can do right away in big integer also. So anyway, I implemented it, and instead of getting some error, I got a time limit exceeded. In handling the big numbers, it just lost its time. That was pretty expected. Like as it multiplied the numbers increased so much in size that you could not handle it after that. And the same problem I've seen people facing in Python. They think that okay, I'll find out the answer, then I'll do some modular arithmetic at the end. I'll do modulo mod. So yeah, but yeah, big
Like
integer definitely at moments it can help you uh, like in a
another
calculated manner.
another thing in favor of C++, and this is a bit of an extreme example, but C++ being very close to the memory is much faster, and there are literally so there's this particular technique called fast Fourier transforms, which on like moderate sized input usually takes like 1 second, but there are implementations in C++ which takes it down to like 30 milliseconds, 40 milliseconds, which is like insane. You can never do those sort of things in Java, but you can in C++. And in ICPC, for example, in particular in NUS, there are certain people who have custom wrote libraries of their own to take advantage of these very fast features. And this becomes a particular this becomes an issue in competitive programming, and I'll tell you why. Uh, in a lot of cases, you can pass like solutions which are not expected to pass, but you can just squeeze them in and like make micro optimizations and so on, and those things are inherently not possible in Java because you have an entire JVM sitting beneath. So you cannot bypass the JVM and directly start accessing memory and poking here and there. But since in C++ you can sort of do it, like there's obviously restriction, but since you can sort of do it in C++, there's a lot more scope for these micro optimizations. As a beginner, will you use it? Probably not. But yeah, for more advanced users, they can make a difference sometimes. I personally have on a lot of occasions squeezed in like suboptimal solutions in C++ that I know for sure would not have worked in Java.
Okay, so I think one point is left unaddressed. Saptarshi told in Java we don't have pointers. So I
Right.
just wanted to ask, don't we need to learn pointers?
Right. So there's a couple of points here. For competitive programming, right? I don't really think pointers are used that much. Like, I have maybe used it, I don't know, 1% of the problems I've solved. Like, it's really not that useful. In some cases, it's good to like pass in pointers, and sometimes in Java, it becomes a headache to like pass those memory locations. But most generally, no. In non-competitive programming cases, which is also a wide field, right? Passing pointers or passing references might not be a bad idea. There are cases where it makes your life much easier to just pass in a pointer or pass in a pointer to a pointer, something like that. Uh, in Java, it becomes an issue. One case that comes to my mind in competitive programming is when you are trying to implement this particular structure called trees. So it's kind of like a combination of a binary search tree and a heap. It's not used that frequently. In some rare problems, it is used. But then the implementation that's usually used, that's obviously in C++, because again, most resources are in C++. They use pointers to references, and initially it might be a bit of a headache, and the code might seem like a black magic piece of code. But then once you kind of get the idea, the code is very succinct, and once you get the idea, you are like, okay, obviously that's how you should write the code, and you just pass in pointers in the parameters. You don't return anything from the function. So the idea is you basically like split a tree across a value. So there, like to split the tree, you kind of need to maintain the parents, and then you just pass in the parent pointers down, and then you keep attaching. In Java, you can't do that. So in Java, you have to like return parent point, like the entire trees as pairs of trees up the call stack, and that might not be the best way to do it. Like, as in that becomes a hassle as to in that it might not be logically that different. You might like translate the code back and forth pretty easily, but writing the code is an issue. like connecting everything together, it is not hassle free. And I think it's one of the most popular use cases of pointers, at least in C++, why it's so helpful. Other cases I might have to rack my brain a bit, but I the gist is clear kind of.
There are even like simple occasions where I've seen that something has been searched. I don't know I don't remember those intricacies of lower bound and upper bound. It probably gives you something in a range greater than equal to a particular value. And then you say that, okay, if it is matching a particular property, well and good. Otherwise, do something like IT minus minus, go to the previous value, yeah,
Right.
and check whether it is dot begin. If it is not dot begin, then, or maybe like check the next one. Before doing minus minus, check whether it is dot begin. If it is not dot begin, then that means you have some value before it. So go to that previous value. I have found use cases on it. And in
Right.
order to translate it in Java, you actually have to do two login calls, two order login calls. You can't get access to do the two things together.
There are more
Exactly.
complicated examples in Code Forces. One of the blogs, I think by Eric To, I had seen like he maintained like memory pointers inside a set, and then directly access the object and like crawled across the pointer. Which, if you did not have pointers, it will add like an extra log factor, like no questions asked. But only if you have pointers, you can do it like in order one time. Things like that. But then again, beginners, will they need it? Definitely no. Treeps is definitely an advanced competitive programming concept. So yeah.
Fine. So, Saptarshi, you like to add some ending points?
Do we have some questions where uh, we might need to answer? I think
More
somebody
than,
asked if I have a channel. So yeah, I don't have a channel. In fact, like
and
even I
someone
don't know whether
also
I have
asked.
a channel, but yeah, yeah.
Someone also asked like, in which language do you teach CP?
Okay, usually I look at the students and
Hmm.
looking at them on 99% occasions, I do have to code in C++. Uh,
So I
thankfully, my
think
code
someone
runs.
was a, I think someone was a C++ a student and saw you supporting Java.
Yeah.
Okay. So
our,
I
our
think,
roles our roles are kind of reversed. Saptarshi likes Java but teaches C++. I like, okay, not in competitive programming, but like I used to teach in NUS like as a assistant, and I used to teach in Java. So it's like opposites.
okay, fine. So like I just wanted to add one point. If we talk about the size of the community of both the languages, then I think we have a larger community for C++, of course. We have larger resources on internet. Anyone who starts a course for any YouTube channel, let's say, or we have different sessions as well. So we see a larger community of C++ only that makes you accessible, more accessible for a beginner, because whenever a beginner will start in any language, he will have several doubts. So for clearing them, he will need to have some kind of assistance. So C++ will be a good choice. And rest and all other points by Saprishi is also valid for Java, starting with Java as well. And yes, if someone is doing in Java, then if he tries to find, so he will surely get resources in Java as well, because many competitive programmers are like top 10 competitive programmer also some are there who code in Java as well. So yeah, so if you like both of them, if you want to add some points, we can add them, or else we cannot, like, no one is a winner here, either C++ or Java. Both are good in their own terms, and you can start in any, like, if you have already an experience in any language, then you can continue it, whether talking in competitive programming. But yes, if you are doing in Java, it will surely help you in your career as well, because when you will switch to some company, if you will work for any company, then Java's concept will help you a lot. I have also felt it when I started my internship. And rest, I don't think we can declare anyone as a winner here. So I just wanted to add, like,
I would
yeah,
also add the disclaimer
yeah.
that currently, due to the projects that I'm doing at Google, I'm requiring to focus more on C++. So
Okay,
C++
so I
has
think,
come back to me. Though that is rare and that has been
yeah, that is
identified.
rare.
That's quite rare. It is a part of our project, but yes, the shifting is not difficult this way as well.
Okay, fine. Okay, so Rajeshi, last point by you, if you want.
Last point. Well, to be fair, like C++ and Java have a lot in common. Like the main code structure is basically the same. So once you know either one of them, it's usually easy, pretty easy to shift to the other. And well, if you are a competitive programmer of the future, start coding in Kotlin. It basically combines the best features of both the languages. Uh, yeah, so I
This
guess
slightly tells me, or rather invokes in my mind, that Kotlin is more connected to Java, right?
yeah, it's basically Java with
Yeah,
like
yeah,
extra bonus things. Yeah,
definitely.
Okay, so thank you so much, both of you, for joining and giving us so much points. And we can also see like, okay, so people are also like voting C++ OP, Java OP. Some are also writing HTML OP.
for competitive programming, just learn algorithms. Language is secondary.
Yeah, sure. So let's end this at a very good tone. And let's thanks our audience for being with us for 1 hour and listening to our points. And let them decide their winner themselves, okay? And let them decide what to start with. So thank you so much for joining us, Saprishi and Rajeshi.
Thank you for having us. Yeah,
Yeah, thanks for having us here. Have a nice day.
Yeah, sure.
Bye.
have a nice day. See you.